Okay, so in the last session, we were just introducing about a new responsibility that you will be taking in day to day, right? So that's about managing infrastructure. So now, once again, just quickly, when I say infrastructure, I'm talking about a combination of certain things like hardware, software, network, and giving access to people with the right permission, right? Now, there could be a new infrastructure that you want to set up for your work, or you might have to modify or update an existing infrastructure. So, this is where we need to know that how do we automate this and make sure we would be able to do these infrastructure management without much errors or without taking much time, and how do you also make sure we can repeat it as much as possible. Okay, so there's one thing that I just want to touch base before we go is, now again, just to give a small idea, when I say infrastructure, it's not just a machine. So let's say in AWS, it's about having the right account, that is the right IAM account or the policies, having a separate VPC, which is nothing but your own private network, and having a firewall, which is security group, where you can say what kind of rules that you should be allowing for the connections, and create machines. Again, for each of the machine, you need to know what is the type of image to take, what CPU or RAM to use, how much of hard disk, so all those things. And assume if you need a load balancer on top of it, then this is also considered as your infrastructure. Okay. Now what happens is, when you're trying to automate, now what you do, as soon as we say automation, you might have to think of writing some script. So even for AWS, one of the popular method which people use to automate your infrastructure is try to use Python. Okay. Now there are a lot of modules available in Python using which you can automate whatever that you need to manage in AWS, right? So instead of writing codes in Python, which is kind of step-by-step approach, right? So the same, imagine this. So this is what I want you to set up. Then whether you're trying to write a Python code or a shell script, right? Then whatever that you do will be more of a step called as imperative method. So technically, imperative means you are doing things one by one, and you have to tell on what is that you need and how to achieve. So that way, like if you are going to do, then you have to write some script which will say, hey, first log into AWS, and in that first create this machine, or first create the VPC, then you create the security group, and after that you have to create machines. So you put everything step by step, right? Wherein you tell what you have to do, on only based on that it will work. So it doesn't have any intelligence to do things by itself. Now, for doing a infrastructure setup like this, you not only have to write everything step by step, then there's a lot of documents that I have to do, right? Same way, like if I have to teach you, for example, that how do you do the same thing using some code, then I have to tell you everything step by step. So this is what the approach most of us would be taking to automate an infrastructure. Okay. Now, in addition to this, there is a issue in scaling, because now you can set up everything using an imperative method by following some document. But suddenly, if I ask you, okay, I need 10 times the same infrastructure like this, or I need 10 machines with the same way of different security groups, then think how much of work that you're going to do if you're following the imperative method. So that way, when you're following the imperative method, it is not a scalable approach. Okay. And the next problem is, your infrastructure that you maintain using the imperative method will be generally what we refer it as a mutable infrastructure. Okay. Now these are the technical words that you should be explaining when someone says, what did you do, right? What problems did you address? So that way, what is the meaning of mutable infra? So think this. You have a machine and you go to the machine, you install something and you start using it for now. Later on, whenever there is a new package that you have to update or new version of a software has to be updated, you just keep modifying everything on top of what you have. Correct? That is what we call it as incremental. So there is something you just add whatever that you need on top of existing or remove whatever is there. So when you keep doing it like this, you will not have a track of the history. So what do you mean by history here? Now, after 6 months, if I suddenly ask you, hey, exactly on 6 months back, for some work, we had set up the infrastructure. Can you please help me to get back the same infrastructure? That is where it is not going to be easy if you manage everything using the imperative method. Okay, so those kind of infrastructure where you will not be able to track a history, and the same infrastructure is what is going to get modified again and again and again, is what generally we call it as mutable infra. Okay, so now on the same, assume you modified something and suddenly I add a new database. Then, if I go right now, my infrastructure will have the information about this. But what if I want to do some work where I don't have the information about a new service that I added? So, can you reproduce it? So, that's when what we need is not a mutable infrastructure, but we need something called as immutable infrastructure. So, what do you mean by immutable? Immutable means anytime I should be able to have a record of what are the changes that I have done, and you should be able to recreate it. So, if I say that 6 months back I had certain infra, can you get me back? So rather than modifying the same infra, you should be able to create a new infra automatically. Okay, so that's what technically the organization or the industry is looking at. Okay, so we need automation, or we need a method to manage our infrastructure in which we are going to have ability to scale our infrastructure, ability to get immutable infra. Immutable means I don't want to modify the same infra. If I want, I should be able to recreate as a new infra with exactly what I want. So that way you should be able to have a history of all those things what you're changing. And what we need is a cloud agnostic solution. What do you mean by cloud agnostic? So today we are using AWS. So let's say tomorrow, for some other purpose, you are using AWS and GCP or AWS and Azure. Then if you are trying to do some solution, you are not going to give the solution only for one service provider. It should be able to work easily on different service providers. That's where the automation that we need to look through should be a way where it should be working the same across multiple cloud. That is when the solution what we need is more of a cloud agnostic solution. And all these things you should not be doing it in an imperative method. So the opposite of imperative is called as declarative. So what do you mean by declarative? So declarative means you just tell what you want, and how to do it should be taken care of the automation. So that is where you don't need to tell everything step by step. So the automation or the management system should be smart enough to take your input, and everything should be done automatically. So most of the tools, as we are going to see in the DevOps concepts, will be working towards the logic of declarative. Okay, so this is something which I want you to remember. So declarative means you tell what is your desired requirement, and the tool will take care of managing, or the automation should take care of achieving it. Okay, so that is what we call it as declarative. In imperative method, or the traditional method, what we do, we tell everything one by one. First you do this, next you do this. Suppose if this works, then you have to do something else. If it doesn't work, then you have to do another step. So that's what is imperative. Okay, so now we have a problem to solve, which is our infrastructure, which could be a new infrastructure or it could be an existing. So now, in order to manage, it could be again a small thing, or it could be the entire data center of your company. So now, if you are given the responsibility, or if you are taking the responsibility of creating and managing your own infra, then you need a declarative approach where you just tell what you want, and the automation should be able to take care of everything automatically, and it should be easily scalable, and it should be a immutable infra in which you are not going to update the same thing. You should be able to recreate and maintain the history. And finally, it should be cloud agnostic. Cloud agnostic means today I'm working AWS. The same way I can easily able to manage Azure or GCP. So that's when we come into a tool called Terraform. Okay. So Terraform is actually a infrastructure automation tool. Okay. So what does it do? So Terraform helps us to create a new infrastructure or to modify existing infrastructure. And at the same time, all the changes that you're trying to do can be tracked in terms of the history, so that I can easily tell what is my infrastructure currently, what was there before that, and I'll be having the ability to go back to any infra and recreate it. Okay, so that way, Terraform is a tool for managing the infrastructure. Now, what is so special about Terraform? So, Terraform works in a concept called as IAC, that stands for Infrastructure as Code. Okay, so what do you mean by infrastructure as a code? So, I was telling you this concept called declarative method, right? So, now imagine this, the diagram that I was showing you earlier. Now, if this is the infrastructure that you need, okay, now you can tell Terraform on what is your desired infrastructure in some code. Okay, so once again, when I say code, it's not a program. There are some syntax. So let's not worry about that. That is what we are going to learn. But now the point, what I'm saying is, if you are going to tell Terraform in some code on what exactly that you need, okay, so just like how we communicate, so now we are communicating using English, or the same thing, you go to your place, your home, you communicate in your native language or mother tongue. The same way, now Terraform knows a specific language. Okay, so we are going to communicate by telling, okay, this is what I need. Now for that, when you say a code, it is nothing but some syntax that you have to put in a file and give it to Terraform. So that is how you will tell to Terraform on what exactly that you need. That is your desired infrastructure. Now, if you take this example, I can tell Terraform my desired infrastructure is I need a VPC, a security group, machine, and a load balancer, and if I want a database. So if I tell that this is my desired infra, and what will Terraform do is Terraform will make sure that whatever the desired infra that you have given is available in actual. So that is how the infrastructure that you need, you are going to tell it through a file by writing some syntax which the Terraform knows. Okay, so that concept in which you are telling your desired infrastructure in terms of some code in a file is what we call it as infrastructure as a code. Okay, and this method is what we call it as declarative, where you are going to just tell Terraform that, hey, Terraform, take this file. In this file, I have written a code where I want a VPC, a security group, and a machine. Okay, and in that, there should be a load balancer. So this is what you're going to tell. And the Terraform will make sure by understanding it, okay, I want to create this, and it will go ahead and create it. In case if it is already available, then it will say nothing to do. Or let's assume the VPC is there, security group is there, but the machine is not there. Then Terraform will say, okay, your desired infrastructure that you want, which you have told me through this code or this through this file, is I need a VPC, security group, and a machine. Okay, but I see the machine is not there. Let me create. Or the security group is there, but you have told that in the security group, your desired infrastructure needs to allow port 80 in the inbound rule. Whereas I do see that the security group is there, but the inbound doesn't have the rule for allowing port 80. So let me update. So that is how you tell your desired infra through a code, and Terraform will make sure that it is available. Okay, so this concept of telling your desired infrastructure through a file in which you are going to write some code, which is nothing but some specific syntax which Terraform knows, is what we call it as infrastructure as a code. Okay, and this method where you just tell your desired infra and Terraform takes care of everything on the other side is called as declarative method. So now I can also tell this in a different way. So Terraform is a infrastructure automation tool which works in a declarative concept where you have to tell Terraform in a file or files where it has the code which tells what is the desired infrastructure, and Terraform will make sure that depending on what you have given, the same infra is available. Okay, now what is the benefit of doing this infrastructure as a code method? So anything that you write as a code, basically you have to write it in some files, correct? Now, where are you going to maintain the files? So as soon as the concept of coding or developing a file comes into the picture, then you should think of version controlling system. And what is version controlling system? It's simple. You have to maintain a repository in GitLab. So that way, today, if I have a desired state, I will put it in a file, and that file is what we are going to store in GitLab. And tomorrow, if I again modify my desired state, again I will modify the same file and check into the GitLab. So this way, every time I modify my desired state of the infra, the file is also getting updated, and you are going to keep a track of that file. That is how, if you ask me, hey, last 6 months back, what was the infra? I can easily go to the GitLab and try to get the exact content of the file, and we can just apply it back. Okay, so that is how, by using the concept of infrastructure as a code, you will be able to version your infra. Okay, so versioning your infra means the desired infrastructure that you are putting into a file. Okay, so that is how it is easy for us to do the versioning. And second, since it is more of a file, you can easily reuse it. Okay, so anytime I want, if I have the file with the exact desired code, then I should be able to reuse it how many ever times I want, right? With some small changes, I can create multiple infrastructures also. And it's also easy for you to test, because now if I want to do some testing of my infrastructure as a code, because let's say I want you to create this VPC, security group, a machine, and a load balancer. Now you don't have to do it in production directly, so you can have a test account in AWS, and you can try to run that using your test IAM, or IAM means the identity management, which is nothing but your account. So you can use your test account in AWS, same files you can run, and the infrastructure will be created in test environment, which you can verify, correct? So this way, what will happen? If there is any issues, you can fix it prior, and then you can try to take that and run it against production, where in production you will have a different account with different kind of permissions. So that is how testing is also easy. So by doing this way of work, in which we write a code in a file, it helps us to minimize the error, and there will be no violations in terms of security. So I don't have to give everyone every permission. Okay, so that is how Terraform, you tell your desired infrastructure and not on how to achieve, because Terraform will take care of it. Okay, and the other benefit is whatever the tools that you have heard about, they are not cloud agnostic, because one common tool which people were using earlier for infrastructure management in AWS is CloudFormation. Okay, so CloudFormation is a built-in service in AWS which also does the same thing, which works in infrastructure as code concept. But the problem with that is CloudFormation works only for AWS. What if your company wants to manage Azure and GCP also? Then CloudFormation will not work. So that's where Terraform can be used against AWS or Azure or GCP. So that way, we are going to learn Terraform and its syntax and whatever is the code that we want, using which any kind of infra that is given to us, we should be able to manage. Okay, so is this first clear on what is Terraform
Yeah,
and
yes,
what's
Adam.
the advantages of Terraform?
Yes, Adam.
Yes,
I have
yeah.
one question. Yeah, Adam, I have one question here. You said, I mean, by using the imperative approach, we cannot maintain the versioning or the. So if you write a Python script or shell script, if you store the same file in the GitHub or GitLab, so GitLab or GitHub, then we can maintain the versioning, right? What we have changed in the infrastructure.
I didn't tell imperative cannot be version. I told imperative means you need to tell everything. Okay, it doesn't have the ability to understand. Now, if you are trying to write a Python script or any script, okay, tell me how will the script look where I want you to create a new VPC, or I want you to make sure that there is a security group available and in that there is an inbound rule 80. For this, what will you do? You have to first write a condition wherein you need to try to search whether a security group is available, and if the security group is not available, you have to write the code to create the security group, and then you have to write another piece of code or function which will create an inbound rule. Okay, this is one side. Other side, if the security group is available, then you have to write another condition where, okay, if it is there, then next try to connect to that, try to read and check whether what are the inbound rules it has, and then validate whether it has one rule which says allow 80. Suppose if it is not there, then you have to write another code to tell to create or add a rule to input or allow port 80. So just for one security group, now if you're writing a script, assume how much of lines of code that you're going to write and how many conditions you have. Like this, if I give you a huge infrastructure that you want to maintain, that is where imperative means you are telling everything step by step. Okay. Whereas declarative means you don't have to tell all those things step by step. You just tell, hey, this is what I want. Whereas how to achieve this will be taken care of the tool. Got it?
Yes, Adam. Yes. Thanks, Adam. It's
Okay, so remember these four words. Infrastructure as a code for which it will be working in declarative method. It is scalable and it is cloud agnostic. And the infra, what you're going to get is immutable infra. Okay, so these are the advantages why we go with Terraform. So this is the logic again, or what we call it as one of the problem statement in DevOps. So that if you have an infrastructure issue, you are going to work in a logic called as infrastructure as a code. And using this, you should be able to know how to solve the infra requirement. Now, with this basics, let's just get little deeper. Okay. Now, what are the features of Terraform? Okay. So the first thing is infrastructure as a code. So that is how Terraform works. Now for it uses a specific syntax or a language which we call it as HCL, because Terraform is available in both open source as well as enterprise. And Terraform is a tool created by HashiCorp. Okay, so that way they use a language called HashiCorp language, which is what we call it as HCL. Okay, so that is what we are going to learn. Don't worry, it's not a programming language, it's just a syntax. Okay, now when you use Terraform, unlike other tools, Terraform has a feature of creating plan. Okay, what do you mean by plan? So before you want to create an infra, the code that you have already written, right? So you can ask Terraform to create a plan for you. So plan means it will try to read what is your desired infra, what is the current infra available, and it will see the difference and it will tell you, hey, this is what I'm planning to do. Okay, so that way, before you are going to apply any changes or create any infrastructure, you will be able to see what and all is actually Terraform is going to do. So that is how anytime before you apply any changes, you can actually see what will be the plan. And in case if you want to change something, you can do that first. Okay, so before applying anything, Terraform helps you to generate a plan in which it will tell you what is getting modified, what is getting created, what is getting deleted. All those things it will tell. And second thing is it internally generates a graph of resources. So graph means there will be a lot of resources which has dependencies. At the same time, there will be some resources which you can create in parallel. So all those things Terraform will calculate, and when you start executing, right, it will clearly tell you that okay, I'm running these things in parallel, and these are the dependencies in which one after the other I have to run. So it helps us to even manage that. So that is how Terraform is smart enough to understand our infra and create those infra parts which is not having dependency. It will be creating it in parallel. Okay, so these are the two main things. So now how does it exactly work if you are trying to look at the architecture? Now all you need is one single machine in which you are going to install the Terraform. So we generally call it as Terraform core. Okay, so when you install Terraform on one machine, then you will be getting something called as a Terraform core. Now after that, all your work will be is to write the infrastructure as a code. Okay, so you can take any machine and you can write your code, and then ideally when I'm saying code, you need to think about developing it and storing it in GitLab. And when you want to run, you are going to put that particular file that you have developed into the machine in which Terraform is running, or where Terraform is installed. So the file that you will be using, right? So internally it will be using the concept or the programming language. Sorry, let me not programming language. So internally it uses the syntax of the code, which is HCL, which stands for HashiCorp language. Okay, so that's how you write the syntax. Now, once you have written and give it to Terraform, so what Terraform will do is the first thing Terraform will do is it will read your desired state. Okay. So, for example, my desired state in the file is I need one VPC, one security group with whatever the ports, and I need two machines and I need one load balancer. Assume this is my desired infrastructure state. So what Terraform will do is it will try to read the state from this file, and then the first thing we will do is we will create a plan. So in the plan, it will say, okay, for me to create a machine, first I should create a VPC, and then I should be creating certain security group to allow, and then I will create a machine, and I can also create a load balancer, or I can create these two things in parallel. So that way, it will try to do a plan in which we will be getting the graph. Okay. Now, once you see this and you confirm that, okay, this is what exactly I wanted, then you go ahead and do the second step called apply. So the first step, we try to plan, and the second step is we apply what is that plan we are going to do. And what will it do in the plan? So whatever the state that you have told, and whatever the state that it has checked and obtained the plan, that it will be applying. Okay. So when it says applying, what it will do, it will go to that exact service provider and it will try to update. For example, if you have told all the state of your infra in AWS service provider, and based on that it will connect to the AWS and it will try to set up that infra, which could be entirely new infra or updating a existing infra. So that is how Terraform works. So you write this HCL file and you give it to Terraform. Terraform will do the first step of generating the graph, and once you see everything is fine, you apply and it will do. Now this is where what Terraform does for this is, in order for connecting to different service providers, Terraform internally uses a plugin which is called as provider. Okay, so that is how when you are developing this file, you need to tell what kind of plugins or providers it has to use. So if you want your infra to be connecting to AWS, then you need to tell, please use the AWS plugin or AWS provider. If you're connecting to Azure, then you have to say, please use the Azure provider. So that is how Terraform uses the provider and connects to the service provider and applies the infra. Okay, so this is just an overview. So you don't need multiple machines. So all you need is a machine in which Terraform core is installed, and the file, which is the other thing that you are going to develop in the infra as a code format. So all you have to do is take the file to the machine and run Terraform. And Terraform will read the state, do the plan, and then we will do the apply. Okay, so this is the workflow. So remember, there is no concept called client and server in Terraform because you are connecting to a service provider. Okay, so then we start working in Terraform. See, the approach that we are going to take is, first, we write the infrastructure as a code. Second, we plan where we see what is that changes that is going to actually happen in your infra. And once you are fine with reviewing it, then you just go ahead and apply. So when you apply, you will be able to create infra which is reproducible at any time. So that is how you can keep a track of what is happening. You will be able to see before itself on what and all is going to modify, and you will be able to recreate. Okay, so this is the workflow of Terraform. All right, so it's more of a concept. That is what you should first know. Write code, plan, and apply. Okay, and anything that you think about developing, you should go back to your GitLab. All right, so with this intro, now let's actually get into another topic of understanding the different concepts in Terraform. Okay, so at least by now you should be clear on what is infrastructure as a code, on a very high level how Terraform is going to work. Okay, now what we need to start learning one by one is, what is that syntax and what are the different commands available in Terraform and how it is going to run. So that's how we'll be taking concept by concept. So just for remembering this, now whatever the file that you're going to write in Terraform, okay, so the syntax of that file, whatever we are going to write, is what I was telling earlier, which is HashiCorp configuration language, which in short called as HCL. Now in Terraform, going forward, if you're trying to write a file, which is written in the HashiCorp configuration language or the syntax, then you're going to end the file with a .tf. Okay, so you can give any name, but make sure you're saving the file as a .tf. Okay, so that indicates that this is a Terraform file inside which it has a syntax written in HCL. Okay, so remember, you are going to store the file with the extension. How many files? We can create multiple files. It doesn't matter. Okay, and internally, this is a declarative language because you are just going to tell your desired infra and Terraform will manage it. Okay, so when you're writing this syntax, you will be seeing a lot of things where you will be writing the syntax in terms of a block. Okay, so what do you mean by block? Block means you will open a flower bracket, you will close a flower bracket, and within that you will be writing some syntax. That is what we call it a block. For example, so just to show you, so there is first block, you will have some flower bracket, you'll close some flower bracket. Okay, I can have another block. Now you're not going to give the name as block, but just to show you what do you mean by block. Okay, and what does this block represent? Some infrastructure. Like for creating a machine, I can have a block. For defining a VPC, I can have a block. So that way, you're telling Terraform whatever is your desired infra, right? So that you get it in block by block. And within the block, whatever that you are going to write will be in a format called key and a value combination. Okay. So what do you mean by key and value? Whatever that the information you are going to give, there will be a key and corresponding to it, there will be a value. Okay. For example, if this block I'm using to represent a machine, then I can say, for example, what is the AMI to use? Okay. Suppose I'll just say Ubuntu 20. Then how much of hard disk you need? Okay. Something like that. Don't worry about these values, but this is how you represent as key and value. Same way, if this block I'm using to specify VPC, then I can just say what is the name of the VPC. Okay, and then we have something called a CIDR block, which is nothing but the IP range for your VPC. Then I can just give it something. Okay, whatever. So like this, we need to give everything block by block, and inside the block there will be key and value. So that is where we need to know what key we will use and what are the values. That specifically depends on the block. So like this, if you open your HCL file, you will be seeing different blocks, and inside the block you will be seeing different key and value combinations. Okay, so using this we are going to tell. So this is just the basics of HCL that we are seeing. So what is that block? We need to see next. All right. Then, when you're trying to write some content in the Terraform file or Terraform configuration file, you might have to comment something. Okay. So if you want to comment a single line, you will use hash. What do you mean by commenting? So when you have a file, when Terraform is reading it, Terraform will read every line in the file. Suppose I don't want Terraform to read this line because this is just for me to understand something. Then I will make it as hash. If I put a hash, then this line is called as commented, and anything on the right side of the comment, Terraform will not read it. Okay, it is just only for the users to see, not for Terraform to use it. So that's where anytime you want to comment something, then you can just give hash. So for each line, you are going to give a hash. For example, I can also give a hash here at the end. This line is to give the OS details. So this way, when you run, Terraform will not read anything on the right side of the hash, but whatever is there on the left, it will read. But it is for a user to understand. Assume that you are opening this file. you should be able to know what is the purpose of this line, right? So that is what is comment. So anytime if you want a single line comment, you can use hash. But if you're going to have multiple lines, then you're going to have asterisk, star, or slash asterisk. Okay. Now, the next thing is we are going to have some variables. So variable is nothing but a place we store a value and we are going to retrieve. Okay, but for doing it, there are different types of variables. So we will get in deeper into it. But just remember, you can store some value into a place and you can retrieve it how many ever times you want. That is what we call it as variable. But for now, all I want you to remember is you're going to write everything in block, and inside the block you're going to give some key and value. A block is nothing but something like this, where you will say the name of the block and then the open flower bracket and close flower bracket. And the file that I'm going to store, I should give a name to it and end it with .tf. Okay. You can give any name, it doesn't matter, but just end with .tf. So these are some of the basics of your HCL or the Terraform file. Okay, and what is this block? How does it look like? That is what we are going to get deeper. Okay, so stop me at any time if something is not clear. So I'm just walking you through one by one. Okay, now, so we know that in HCL, we will write a file with the extension .tf. We are going to give everything in block by block, and inside a block, you're going to have a key and a value. Now, to start with, there are different blocks that you will have in Terraform. Okay, so we will try to learn one by one. So the first important block, what you're going to have in your HCL or the Terraform file is called as the provider block. Okay, so why do you need the provider block? So in the architecture I was telling you, right? So you have to tell the Terraform what is your service provider and what plugins it has to use internally. So that's what we have to tell through provider. So a provider block is a block using which we will be able to tell Terraform on what is the cloud service provider to which Terraform has to connect. Okay, whether it's AWS or Azure or any other infra that you want to connect, then that details is what we are going to give using this provider block. Okay, so how does this provider block look? So when you're trying to create a block for the provider, you will have a keyword called as provider, followed by the name of the provider, and within that, whatever the details that you want to give. For example, if you're trying to specify AWS, then you will have the block something like this. Okay, so now with the same syntax, if I open, I'll be having a block where I will say provider. Okay, and then the name of the provider, which will be AWS, and open flower bracket and close flower bracket. Okay, then within this, now if you understand for AWS, what and all you have to do. Now, if I am connecting to AWS console, then I have to give the details, right? Like what is your username and password, or what do we call it as the credentials, and then which region it has to connect. So whatever that information you want, you are going to give it in key and a value. Okay, so what are those keys we will see, but just understand the first provider, I mean, the first block is the provider block, which tells Terraform on what is the service provider to which we are going to connect. So here you will say provider and the name of the provider. Okay, so remember the syntax. Now, after the provider block, the next block that you are going to have is called as a resource block. So usually When you open your Terraform, you will have only one provider in the file because for one infrastructure, you will be connecting to only one provider, right? See, even though you might have different things needed on different cloud, but when you say a infra, I cannot create a VPC in AWS and a machine in Azure. That doesn't work. I can have a separate VPC and a machine in AWS, and I can have a separate machine or a database in Azure. So that way, we need to think how it will connect. But logically, one infra that you talk, you should have one provider. Okay, so it's not mandatory to have multiple, but usually one provider block will specify the plugin. However, inside a service provider like AWS, whatever that you are going to create is called as a resource. So let's go back to the same diagram earlier. So now if my infrastructure I need is VPC, security group, and then load balancer and machine, then each of them is considered as a resource. And for each one of them, whatever the definition you are giving, you need to give it as a block. So in your Terraform file, you will have one block to tell about VPC, one block to tell about security group, one block to define the state needed in load balancer, and one block to define machine. So this is how you will be having multiple resource blocks. Okay. And for each resource that you need, there should be a block or a resource block. Okay. And now, when you are defining a resource block, you will always give the keyword called resource, and followed by that, what resource provider it is associated. Now, if you are trying to create a resource block, a resource block is specific to a provider only, because if you want to create a machine in AWS, the resource is called as EC2. If you want to create a machine in Azure, the resource name is called as VM, right? That is how the resource block, whatever you are going to use, is once again specific to the provider. So that is where you are going to give what is the provider and what is the actual type of resource which is associated to the provider, and then you give a name which is something we keep, whereas the provider and the type is what you need to find out and identify for a provider like AWS. What are the different resources that you can create? So based on that, you need to find out the name and you have to give it. Okay. And to identify this resource uniquely, you are going to have a name, which is what you are going to give. So to understand it better,
So
if I
indirectly,
go
you're saying
to
that it's
Azure,
a completely. I'm sorry, interrupt you. Yeah, indirectly you're saying that it's a completely hard coded, because like whatever the mission which we are wanted to create, and the desired mission which we need to give every information. That's
it's
all.
not
We
like
cannot
that.
change it.
Not, no, no, no. It's not that way. How does Terraform know to create a machine? So you have to tell in a resource block. So to tell Terraform that the resource that I want is a resource related to AWS, then the first thing you need to give is the provider block, which is AWS. And then in AWS itself, there are thousands of resources. So which resource exactly should Terraform handle? For that, you need to know the type. Because now, if I tell you to create a machine, you go to the AWS console. In this, there is a service called EC2. You click this. Okay, so when you click on this, it redirects to a dashboard. So that is where you will create a resource, whatever you need. But how does Terraform know? And Terraform is going to do all those things in background programmatically, right? And that is where you need to find out what is that syntax or the block which exactly tells Terraform on what resource you want to create. So that is where, if you go to resources in Terraform, it has plenty of resources available. Okay, so the first thing you need to know is what is the service provider, and for the service provider, what are the resources available. Okay, so you can also go to the, okay, and I can go to providers. Okay, so here you can see there are a lot of providers that internally it connects to. Okay, so you can have a look. But specifically, if you are interested in a provider, then you can check. And for each provider, there will be specifically a resource block. Because in AWS, like how you go here and see different resources using the UI, we are trying to write everything in some kind of code. So for that, let me quickly say Terraform AWS provider. And if you go, okay, so this is the provider. Now it just gives you example on how to use the provider block for various things, which we will see. But on the left hand side, you can see that for this provider, these are all different resources. And for each resource, there is a resource block. So this is where what is your interest. So you want to create a machine, then you should exactly come to here. And in this itself, you can see what are the different actions you can do. Okay, so based on your need, you need to find out the exact resource type, and in that you are going to give the value which defines what is the resource that you want to create or modify or update. Okay, so that is where this is called as the resource type. Okay, so for
Oh,
example, if I want to create a machine, then I need to first create a provider block in which I will tell my user details and my region. And then if I want to create a machine, then I have to create a resource block and then the type. So the type is AWS underscore instance, which is nothing but this. So using this, I will be able to now tell to Terraform that, hey, I need a machine. And then you need to give a unique name to identify this because there might be multiple resources. So to each resource to identify, I can just say like this. And here I can give a block. And within this block, I can tell what AMI I need and what security group I should use and what hard disk that I need. You know, those values you can just give it here. So like this, for instances, suppose if I want to create a VPC, again, I don't want to create a VPC. I just want to tell Terraform that Terraform, I want a VPC to be available. So what is the details? So then you are going to create a resource block. Now what type of resource it is? It is based on AWS. So the type of the resource will be AWS underscore the name. So that is where it's more about practice where we have to search. Now for creating a VPC, now like this, see just for one service, there are so many resource block. Then I need to search for VPC. Okay, this is the one. And in this, you again have so many resources. Now out of that, I'm trying to create a VPC. Then search for this. Okay, so now this will be helping me to create a resource. So here I will say this. So by looking at it, you can understand that this is a resource for creating a VPC under AWS. Okay, and then the name for it. So you can say my VPC or something, and then the data. So that is how for each resource that you need to be available in your infra, you need to create a resource block. Okay, so we'll get in deeper to understand, but going forward, for every resource, remember you will have a resource block which starts with the keyword so that you can identify that it's a resource type which starts with the provider underscore the type, and then the name. So this is something which we can give. Using this only, we will be able to easily identify or get some details. So that's how the two important blocks that you're going to have as of now. One is provider block and then resource block. Okay. So again, all these things are some basics that we are going through. Okay. So as we move, we will get deeper and deeper. So is this clear until now? So anytime when you open your Terraform file, you should see a provider block and you should be seeing multiple resource block. Okay. So for every resource that you need, you're going to have a block for which you need to first identify what provider to use and what is the type of resource that you want to use. Now, it might look a little odd because every time you cannot search, but it comes through practice. If not, a simple way to do is ask Google on what is the type of resource or just go through this and try to identify. But that way, let's get hands-on and then come back to some examples. Okay.
So Adam, can we mention the two providers in a single file?
You can, but logically, as I said, it's not a day-to-day use case that you're going to do. Okay, so for now, think of having only one provider.
Okay.
Adam, it's on day-to-day basis in real time. Like what kind of a tasks will come actually? Because every day can we going to create it's like these resources which is on the AWS and the Azure environments, or with the existing environment only we going to create the changes, right? What kind of a tasks will come actually?
Yeah, we'll discuss about that. But before that, what I'm trying to tell you is whether you're going to do something once in a while or whether you're going to do very frequently in a day, let's understand the logic. Then let's come back and understand the difference. Because, like I said in the beginning, if your responsibility is to taking care of the entire data center or doing the entire administration of cloud AWS, then you will be managing the infrastructure completely, right? So in your day, that itself will be like 70-80% of the work. But for any other case, you have to now showcase your talent saying, hey, it's not that every day I will create a machine or a VPC, but for any kind of my responsibility, which is there in development or testing or deployment or managing a database or whatever it comes, I know the ability or I have the ability to just create the infrastructure. And for that, you're going to use some automation, which I can reuse. So that's the whole logic what we are trying. Okay. So when to execute, what to do, we will see. But before that, that's how we are trying to learn because we are not going to restrict ourselves that, okay, if I'm not going to do administration, then let me just learn only that part. No, we want you to learn in such a way that given an opportunity, you should be also able to do the management completely. So that way, the amount of work we will discuss later, but let's go back with the common concepts. Okay.
Okay.
Now, there are different ways that you can install Terraform. So what I'll do, I'll just change this to 30. Now, since Terraform is rapidly getting developed, right? So you will see a lot of versions available, but not every version is stable. So you can use 13 or 14. 15 is also available in Terraform, but I would prefer use 13 or 14, but preferably I use 13. Now what we can do is you can install Terraform as a package, okay? But this will install the latest version. So if not, you can choose a particular version, download the zip, and then install it. Okay. So this is what something I prefer. And for different versions, you can check into this. But before that, I need a machine for this, right? Now, in an organization, ideally, you're going to have a separate machine for managing Terraform. So you're going to take a separate machine. You can take whether it's a Windows or Linux, it will work, and it doesn't have on any preference on which OS. It will work on both of them. So for us to make it simple, I'm still going to use a Ubuntu machine. But if not, think that you need a machine to install Terraform core and run Terraform from that. Just one machine. So for that, now instead of recreating a new machine, what I'll do, if you go back, you already have one machine which you have created for Docker, right? So I can just reuse it. Okay. If you want, you can create a new machine. That's not a problem. So I'm just making sure that I'm recreating. I mean, instead of recreating, I'm just reusing. So I'll quickly start this. Okay. By the time it comes, I just want to install this. All right. So, all right. So this is running. Okay. So once again, I'll switch the user to root and let me download this. Okay. So you should see this file. Now let's unzip it. Sometimes you might not have the unzip utility itself or package. So let me just install it quickly. Okay, so now that unzip will be available. So let me just go ahead and extract. And while I'm extracting this zip, if you actually see, there is only one file inside this zip, which is the Terraform binary. Okay, so I'm directly saying extract this to the folder called user local bin. You can put it to any other location, but just make sure that Terraform is available in any of the folder which is referred in the path variable. Okay, so I'm just going to run this. Okay, so it's directly extracted. Now let me just clear the screen. So if you just say which Terraform, you should see it's available. And to cross check Terraform version, so what we have is 3. Okay, so let's not worry about this message. So right now I'm using Terraform 13. Okay, so you have Terraform now. That's all. So let's get started with other things. Okay, now before we get into the commands, let's take an example and let's try to learn what is the workflow one by one. So,
Sorry to disturb. Here the Terraform we installed on the cloud machine, so we can install on any machine, right?
yes, you can install any machine.
Okay.
So let us take the first example. Now, before we jump into creating infra, let's get little hands-on on Terraform to understand. Okay, so that is where, let me take an example where using Terraform, you can communicate to a Docker daemon also. So it is not an infra, but practically there are plugins available where you can use Terraform to create and manage a container. Okay, or basically you can communicate to the Docker daemon and get the things done. So this is where first let's understand certain concepts of Terraform using this. And once you understand the logic, then we can go ahead and apply this to AWS so that it will be easy. If not directly, if you go to AWS, it might be too confusing. Okay, so that is where now, if I want a Terraform to connect to AWS, then there will be a AWS provider. The same way, now I want Terraform to communicate or to handle a container infra, just assume. So what do you mean by container infra? There is nothing like that. But For me, it's just about what container to create, what image to download, those kind of things. So that way, now, as the basics I told you have to write a file called terraform.tf. Okay. And in that, you are going to put a content in block by block. So the first block is provider block, and the comment will be in hash. And this is the name of the plugin or provider which we are telling Terraform to connect. So this means we are telling Terraform to connect to a Docker daemon. Okay. So unlike AWS, Docker daemon is a tool which should be running in one machine, right? So that is where we need to tell on which machine that Docker is running or the Docker daemon is running. This is the reason why I installed Terraform on the same Docker machine so that the Docker is also running on the same machine, so Terraform can simply connect to it. Okay, but doesn't mean that you need to have both of them in the same machine. Terraform can also connect to Docker daemon available on another machine also. But for that, you need to set up the network. Everything should be proper. So without those kind of issues, I can make sure if Docker daemon is running on the same machine, Terraform can easily connect. And that is where the details you are going to give in a key and a value. So this is how there are different ways that you can give. So you can give the details of where is the Docker daemon running, the machine details using SSH, or you can also give the IP address and the port on which the Docker daemon will be running. Okay. Now, instead of all those things, one simple way for you to practice now is if you give this, Terraform will be able to connect to the Docker daemon on the same machine where it is running because Docker runs on a socket, and that socket is what Terraform is going to read on the same machine. Okay, so this is the first thing we are telling. Now, when you take Docker provider, what are the resources that it is going to have? So the major resources, if you see in Docker, is creating an image or creating a container, right? So that is where for the Docker provider, we have a resource block for creating an image, and that is this. So you can see resource and Docker underscore image, which is nothing but the provider underscore resource type. And then what is this? It's a name that we can give to identify this block. Okay. Then what is this? So this is a key and a value wherein for this resource block, I'm telling what is that resource that I want. So the meaning of this resource block is if in my machine or whatever the machine in which you want this to be connected, if there is no image called CentOS latest, then the Terraform will download the image and keep it, for which it will tell the Docker and get the commands. So that is where you don't have to worry about giving the commands or instruction. Okay, because here you are telling the desired state. So you are telling that, hey, I need an image. That's all. So it will automatically download the image from the registry and keep it. If it is available, then it will not do anything. So that's how we can do the plan and we can see. Okay. So now there are a couple of things I want you to do before you jump in. So first, go back to the machine, cross check your Docker is running. Okay. Then here, if I say Docker images, you should be seeing that CentOS latest is already available, right? But anyway, we'll try to see. Now, first thing I want you to do is when you start working in Terraform, create a folder. Okay, any folder that you want. So I'm just going to name it as Terraform. Okay. Now I don't need this file, so let me just remove this. Okay, so I have created a folder called Terraform, and All those examples that I'm going to try will be inside this. Okay. And remember this rule: going forward, any Terraform file that you are trying to write, you need to have a separate folder for that. So for every example or every infra that you're going to create, you need to have a separate folder. Okay. And inside that, you're going to put all the files. So we will see the reason why. Okay. So first I'll say is, I'll say ex1, okay, which is nothing but example1. So I can give any name. So let me just give this, or I'll just say doc, which stands for Docker. Okay. So let me go inside this Docker folder. And in this, the next thing is, when you're trying to write a file, always the first file that you should write is give the name as main. That's again a reason on why you should keep. We will get it a little later. But the name, I'm ending it with .pf. Okay. And then copy paste this. Okay. Okay. No, this is not the name of the container. This is the name of the resource. Okay. So name of the container we are not giving. So if we don't give the name, it will be creating some name. And moreover, we are not even creating a container. Okay. So what we are doing here is trying to download an image. If you want container, then we should have another resource which says container. Here we are talking only about image. Okay. Now, what did we do? So I just want you to create a folder called Terraform, and inside that you can create any folder, example, doc, whatever I want. I created. Now go to this folder, and the first thing I want you to do is create a file called main.tf and put this. So this is what I want you to do. Like this, going forward, anytime I want a file to be created, then I will create a separate folder, and inside that I'll be putting all those things. Okay. Now, so we have this file, which is what we call it as the Terraform file, and it contains the HCL. Now, the first time when you create a Terraform file, what you need is, you need to tell Terraform on how it is going to connect to your provider. Okay. But for that, we just have Docker here. That is fine. But it doesn't have anything else other than your Terraform installed. So we need to first download the plugins needed for managing the resource. So that is where we need to do a step called as Terraform init. Okay. So Terraform init means initializing your infrastructure so that Terraform knows that it needs a plugin for Docker, and related to it, there is some resource. So it will not create the resource, but we are preparing Terraform to tell that, hey, I want you to understand that this is a Docker based infrastructure. So for that, whatever the details you want and the plugins you want, you read it and prepare yourself. So that is what we are trying to tell in the first step. Okay. And you need to run this inside your folder where you have your .tf file. Okay. So remember, this is only on the first time. Okay. So now go ahead and do a Terraform init. All right. If you get this error, this is only on Terraform 13 where the Docker plugin is not available on 13. So we need to upgrade the 13 to 13.4 or 5, whatever is available. So let's not worry. And moreover, in real time, you will not be doing, since I'm just using the Docker example and specifically 13.0, it is giving me this message. So all you have to do is go ahead and run this additionally. Okay, so give a S. So it has updated our Terraform internally, the version, and then just go ahead and do a Terraform init. Okay, so it see that it has downloaded a plugin for Docker, which is 272, and it says this folder it understands. So now from this folder, if you try to do any Terraform actions, Terraform does know that it will connect to the Docker daemon, where it is, and for that, what are the resource block that you have given, it will be able to know that. So that way, before running this only on the first time, you need to also do this stuff. Okay. Now, how do you cross check that Terraform init is done properly? So go back, clear the screen. This is a new file which is created. Now, this is created by running the Terraform upgrade. So you can ignore this file, it doesn't matter. But in this folder, if you do -a, so you can see there is a hidden folder which has got generated very recently, because this file is what we created, and when you did a Terraform init, it created this. So what do you have this, what do you have this content here? If you see, it has plugin. Okay, so what plugin? If you just dig in a little deeper, you can see it has the provider, and the provider is nothing but Docker. Okay, so this is what it was trying to show you earlier when you did the Terraform init. Okay, so it's exactly downloading whatever the plugin it is needed based on your operating system. Okay, and it is trying to take the latest version. Suppose if I want, I can also tell a particular version of the provider that I want. For that, I have to add one more entry here, sorry, in the provider, and say the version of the provider. Now let's not worry about those. So I'm just going to take the latest Docker provider, which is 272. Okay, now this is what the Terraform init does. So now in this folder, Terraform knows about the Docker provider. So if you do a Terraform init once again, it will not do anything. It will just say everything is initialized, nothing to worry. Okay. So remember, it's only the first time that you have to do a Terraform init. Okay. So you have initialized this folder, and Terraform knows about your Docker provider. Now, what is the next thing? The next thing what you're going to do is Terraform validate. What do you mean by validate? So usually what you will do, you will not be doing init always. Okay. So anytime you write some code, which is this TF file, and you want to check whether the syntax of these things are correct. Okay. Whether there is no issue, have you written everything proper? Have you used the right way to put this block? So that is what is the Terraform validate is going to do. So just like how you are developing some program and you have to cross check, Terraform validate will be useful. So it says it's success. So whenever it says there's an error, then you need to find out which line it is telling and what is the syntax error that you have done. Okay. So as we go along, we'll see that also, but just get used to this. So as soon as you write the code, the first thing you are going to do is Terraform validate. Okay. Now, after Terraform validate, so what we are going to do is the next step called Terraform plan. Okay. So what do you mean by plan? So that's where I was telling you in the beginning. Now, what is that the infra that we are telling to Terraform? You need to download an image. So this is what we are telling. All right. Now, before you go ahead and apply this, if you want to know What exactly is Terraform going to do? That is what we will be seeing using a plan. So Terraform will clearly tell whether the resource has to be created or whether the resource has to be deleted or whether the resource has to be recreated or nothing to do. Whatever you have informed is already available. Okay, so that way Terraform plan will show. Now in that, Terraform will try to give some output wherein if it shows a plus, so this indicates creation. Okay, now if it indicates hyphen, then this indicates resource deletion. If it indicates uh, plus or minus, then it's resource recreation. Okay, so you will be seeing that details. So using that, you can understand, oh, there is something available or it is not available. Terraform is going to help you in creating or deleting or recreating. Okay, now let's go to a Terraform plan. Okay, so you can see it clearly says that there is no such image called CentOS latest. So it is going to download and ensure that in your machine, the CentOS image will be available. So that's the reason it says there is a plus. And what is that resource? That is nothing but this one. So going forward, if I want to identify that resource, I can just say this is the unique name using which I can identify. So this is the type and this is the name. So it also exactly tells you where. And this is the total details of the plan on how many created, how many changed, and how many destroyed or deleted. So right now there is nothing else to change or destroy. So there is only one resource which needs to be added. See, technically, it thinks that it's a machine and other things, but it's just a container, wherein you can see there is one resource. Right now, we have only one block. That's okay, but that is what it is trying to do. So every time before you do the changes, you need to do a Terraform plan. Okay. Now, after this, you are going to use Terraform apply. Okay. So what will apply do? Apply is where whatever the plan that we have generated, this will be applied. Okay, so what do you mean by that? Now Terraform is clearly telling that based on your desired state, it is going to make sure that there is one image downloaded, and this is it. So that is what, when you say apply, it will internally do. So all you have to do is plan and apply. That's all. You can do directly apply, but that's not the right practice. So when you do a plan, you will be able to see what and all is getting actually modified, because that will help you to double check. By mistake, if you have given a wrong infra state, then after creating, you cannot fix, right? It will take a lot of time. So instead, you can simply go ahead and do a plan and find out. And whenever you're doing apply, okay, Terraform will be ensuring that you are not doing it by mistake. So when you say apply, it will go to the plan and it will try to read what is the plan that you just now did. And based on that, it will ask for confirmation on applying it. So by default, Terraform apply, or when you do destroy, it will ask you. And this is where I'm fine. So go ahead and do a S. So when you enter, then you can see it is trying to show you that it has downloaded an image and the ID of the image is this. Okay. Now, at this place, there is a resource which is already available. So when I say Docker images, You should see CentOS latest is available, and what is the ID of it? Now it is keeping a track, right? Now at this time, let me clear the screen. Let us go back and do once again a Terraform plan. This is where you are telling the desired state is you want an image. That is the resource that you have given in the resource block. So when I say plan, okay, so what is it doing? So it is trying to tell now that there is a resource that you wanted, okay, and that resource quickly it is comparing and it is trying to tell nothing to be done because the desired infra what you want is to make sure that there is an image available, and Terraform is saying, hey, that image is also available and the ID of the image is this. So this is where there is no changes needed because whatever you wanted is already available. So that is how even if you do a Terraform apply now, it will not do anything because infrastructure is up to date. Only when the Terraform plan says that there is some changes to be done, and when you do a Terraform apply, it will change. If not, there is nothing to change. Everything is up to date. Okay. Now, if you want to identify a resource, then you need to identify the resource using interpolation, in which you will be using the resource block type dot the resource name. So that is where we are giving this unique name that is needed for us to identify. Okay, because as we move along, there will be different types of resources we will have. So uniquely to identify, we are going to use this particular name. Okay, so I'll just get one by one. As of now, if you see, Terraform plan is clearly saying that there is infrastructure available and everything is up to date. So this is how only when there is a change, Terraform will say, and when you execute the apply, it will take. Now, however, when you're running Terraform apply, when there is something to modify, it will ask you for approval. So if you want to suppress that, then while you're running, you can say auto approve. And when you run this, it will try to suppress and it will not ask you to press S. It will go ahead and directly run. Okay. Now, whenever you have already created an infra and you want to know what are the resources that Terraform is managing for you, okay, and the details about that if you say Terraform show inside the folder, okay, and you can see clearly it's saying that it is managing a resource and the details of the resource is this. So this is what, when you say Terraform plan, automatically it brings up and says, hey, you wanted an image, there is already an image of CentOS latest and this is the ID, and that is how it keeps a track of everything it does. Okay, so it tracks the state. So in the state, what resources it created and what is the details of that, it also maintains everything. So if you want to see that, you are going to say Terraform show for it. Okay, and at any point of time, if you want to destroy the entire infra, okay, then whatever that you have defined in your TF file, if you want to destroy all the resources, then you can just go ahead and say Terraform destroy. Okay. Now, you are not going to do this in day to day, but for practicing, you can just practice, because once you have done everything, you can go ahead and destroy it. Okay. Now, this is where, even for example, if you are creating a machine, now after I finished my class, I just want to destroy it. I don't want to keep. Then, rather than going to that console and running, I can just quickly execute a command and Terraform will connect to the provider and finish the work. So simply now, if I say Terraform destroy, Now, once again, it'll ask me to confirm. And this is where you can see a hyphen is indicating that one resource is getting destroyed. What is this resource? This is the one. And you can see, so you can just go ahead and say yes, and it's destroying now. And once it is done, if I go to Docker images, you can see there is no CentOS latest. So at this time, when I now come back and say Terraform plan, it should clearly tell me that there is a new resource to be created. And when I try to do a Terraform apply, this time it will create. So that is how you tell the desired state, and Terraform will be ensuring to bring it up. Okay, because I'm not giving any kind of commands here. So Terraform apply, auto approve. So you can see without asking to press enter, it goes ahead and it is creating the resource. Okay, there you have. And this is the ID. And if I say Docker images, you should see. And now once again, if I do a Terraform plan, it should say nothing is needed because whatever the infra you wanted is up to date. Okay. Same way, if I want to do a destroy, I can simply say destroy and it will delete. Okay. So whatever that you are defining in your Terraform file, Terraform will be able to manage that. For this, this is what we call it as the Terraform workflow. Okay, so whatever configurations we are going to write going forward, forget about this. This is only for this demo. But if not, the first time you are going to say init and then validate, plan, and apply. And see the details using show. And if you do not want the infra anymore, go ahead and do a destroy. Okay, so I want you to get comfortable with this because as we move forward, this is what we are going to run again and again and again. Okay, but you need to know what to run, when to run. Okay, so before I jump, any questions on this part, what we did as a workflow?
Uh, Adam, I have one question. Suppose if we manually delete any resources, how this Terraform will track?
What is that?
We have created the resource via Terraform, right? Suppose if I manually deleted the resource, this Terraform, how this will be tracking?
It will try
Or,
to recreate. See, that is what.
okay. Mm.
If you delete, then what's the difference? So Terraform will clearly tell that you wanted a resource and that resource is not available, and it is that is where it is going to cross check and it will say that okay, this resource is absent, so let me recreate it. So that's the whole point. So you're not going to tell to recreate or delete or do something. So you tell that this is what I want. So Terraform will check what you have told, and Terraform will check what is available. Whatever you have told is not available, then what it will do, it will just try to recreate it. Suppose if that machine is already available, it has a unique ID and Terraform will track it. And next time when you say, hey, I want to create a machine, if that machine is already available, then Terraform will say, infra is up to date, nothing to do.
Okay, okay, fine.
Adam, like init command, will that create a bridge between the provider and the resource, or it creates the bridge between all the Terraform provider and the resource?
Yeah, so it is more for Terraform to know what are the types of resources that it is going to take. Okay, for that, it is only for downloading the plugin or the provider, nothing related to resource. Only when you do the plan, it will read the file and know what to do. But the first step in it is to download whatever is the plugin needed to read your provider block. Okay, So the Terraform init is mainly for the provider block.
Adam, I have a
So how
question.
that is associated, like resource and a provider, how they both are associated to each other based on the resource name only, it has that intelligence to link between those two.
Yeah, because this is a name that we give, whereas this, whatever that you're giving, is a specific keyword. Now, if you give Docker image, definitely the meaning of this is the provider name is the first one. That is what in the PPT or the slide that I was showing. So this name is what the provider that you have given. So obviously, whatever the resource that you have here is associated to this provider, and that provider is what you are telling in the beginning. Okay, so every resource type is specific to a provider type. Okay, you cannot use any name here randomly, whereas this is a string for us to identify. So that is how you declare the provider, and for the provider, what is the specific type, which is where now, for example, if you go here, okay, now let me just show you Terraform Docker provider. Okay, so now for the Docker provider, if you go and check, you will get to know what are the blocks or the resource block which is going to available. So here these are the different provider blocks, different resource blocks that you have for Docker. Out of that, I'm just showing you only the image. So if I want container, then I should use something else like this. So the name is what is important.
Yeah, thank you, Adam.
Adam, I have a question.
Yes.
Suppose if we have created multiple Docker images, and when we do destroy, will it delete all the images?
No, whatever that it is tracking, it is going to destroy only that, because this is where what is the state you are dealing. See, everything is from this file. So whatever the information you have given in this file, that is what it is going to manage. Okay. So to understand anyway the question that you said, now let me go ahead and do a Terraform plan. Oh, sorry, Terraform plan. So it says that there is one image it is going to create with CentOS latest. So Terraform apply. Okay. So now if I do a plan again, it would say that it's already available, right? And you have CentOS here. All right. Now watch what happens here. I edit my main.pf. My desired state, instead of CentOS latest, I will say I need CentOS 7 image. Okay, not the latest image. Oh my God. Okay. So now what has happened? My desired state I have modified. So let me do a Terraform validate, Terraform plan, and see now what does it say. Do you see it is getting updated? So that is where it is saying earlier the state what it was managing is that there is an image which has an ID of this, which was nothing but CentOS latest. But now you are trying to change it from CentOS latest to CentOS 7, okay, which is nothing but this. So the resource is available, okay, but you have modified the state. So that is where it is saying it is updating the resource. Okay, so in that case, what will happen? Now, instead of having this ID, it is going to bring a new ID and replace it with the existing one. But it doesn't mean that it will replace the image name. The information which Terraform is maintaining, that will get updated. Okay, so now nothing to be destroyed. It's just going to update. So this is where if you just say Terraform apply, and you should see that it's modifying this image. Okay, and the new ID of the CentOS 7 image is 862. And now if you go back and look at it, what you have is CentOS 7. Okay, now Terraform doesn't care about this. It is just saying that, hey, you told me the desired state is this and it is maintained. Okay, and that way, now if I say Terraform show, what is it tracking? Now it started tracking this because this is your desired state. So whatever was there earlier, I don't care. And that is where every time I modify, if I check in that file and push to GitLab, then I will have two versions. So if I want to go back to the previous one, then I can download the previous content of the main.tf. And then if I try to run a Terraform plan, it will update your spec, or if your state is getting updated, and it will tell you. So this is how, if I say Terraform plan, it will say nothing to modify, because what is the desired state that we have? You have the desired state as the image into a 7, and what it has is also the same. So that's where Terraform plan will clearly say that there is nothing. But if I do a Terraform destroy, then this is where it is going to destroy what is it tracking. Because in your main.tf, you have told the state that you want is a CentOS 7. So when you say destroy, if it has created the CentOS 7, or sorry, downloaded the image, it's going to delete only that. And now if you go to Docker images, you should see CentOS latest is available because Terraform just moved the resources reference from CentOS latest to 7, but it deleted only the 7. Okay, so whatever you give in your state, that is what Terraform is going to track. Got the difference? So this is how you keep updating your configurations, and Terraform will be managing everything. Now that is where, before I do update, then I should have done a Terraform destroy for CentOS latest, and then I should come back and do. But this changes from resources to resources, because there are some resources in which when you do some changes, the existing resources itself will be updated or recreated. So that depends on the type of resource. So as we see, we'll try to understand those different behavior. But Terraform clearly tells you that what is your desired state in the file, and based on that, what is it available in your infra, and based on that difference, what it is going to do. Okay, so that's how it is going to maintain.
Like Adam, I have a question. It's like, because if I wanted to destroy, if I wanted to use the because I have created multiple images, multiple Docker images, and but a specific one image, if I wanted to delete it, like how it is possible with a destroy command? I may need to
Okay,
change the file.
no, it's not like that. So first question is, how did you create multiple images? So one thing you can do is, you can have multiple resources here. Okay, and while destroying, you can exactly tell which resource you want to destroy. If you don't tell anything, it will destroy all the resources. But a good practice is, when you try to create the file, you can create it with 3 resources. That is, 3 times you will say Docker image, Docker image, Docker image, and in that you give different images. That way, when you apply, it will create all the 3. However, while you destroy, you can choose which one you want to destroy. But the next time when you try to do a Terraform plan, it will clearly say that this particular resource is not available. Okay, but if you say, I took one file, I first did the CentOS latest, I applied, and then once again I changed this to CentOS 7, I applied, and then I changed this once again and did a apply. So Terraform is going to just blindly keep updating its information based on what you have told. So right now, when I say Terraform plan, It just knows what is the recent one you have. So that is how Terraform doesn't know anything about the previous one directly. So what is your current state, it will maintain. So that is where if you are doing this kind of work, then you need to check in this file 3 times and you have to download the specific version or change the version of the file to whatever the content you want and then run Terraform plan. It will try to read that current file's content and run. If not, as I said, we are going to put multiple resource blocks. Okay.
Yeah. Okay.
Adam, can you please
So that's it.
tell me from which step it will start tracking?
Which step means? From the
It
apply.
will apply, right?
Hmm.
Okay.
When you
Thank you.
say plan, if there is nothing there, it will not do. But only when you do a apply, it is going to basically keep a track. Okay. Now let's take another example to understand this better. Now in this example, what I'm trying to do is, okay, I'm trying to create one more resource. Okay. So this time I want to take an image which is Nginx. Okay. And I want to create a container out of it. Now that is where you can see there is another resource block called docker underscore container, wherein this is the provider and this is the type of resource. So by giving a combination, we are telling to Terraform that this is a resource of the type container for the Docker provider. And this is just a name for us to identify. Now, what are some of the details that you're giving here is, you're trying to tell the name of the container, the image that you want to take, and what are the ports that it has to be associated, like the port mapping. Okay, so now if I go back, now either I should be creating a new folder. Instead, what I can do is Terraform destroy. Okay, so it says nothing to destroy. So let me open my main.tf. So here,
Adam, you have not. I can't see the image name here. Like name of the
yeah, we'll
image.
come to it. We'll come to that. Don't worry. But just see that we are trying to give the reference. Okay. So right now, I have two resources. So Terraform validate, Terraform plan. So now you should see there are two resources. One is the image and the other one is the container. Okay. Now here it's saying this is the resource, but for that resource, there are so many properties that is going to get created. Those details it doesn't know. Why? All these things will be created only, I mean, applied only after the container is created. Then Terraform will update itself. As of now, it says that, hey, I don't know anything. So that is where only when you do a apply, it will create and it will try to store all the information. Okay. And now if I go ahead and say Terraform apply auto approve, so it's created. And now if you do a Terraform show, you can see this is the ID of the image. Come back. This is the details of the container. What is that container running and what command, what is the startup command, what is the unique ID of the container, all the details it's going to track. Okay, so to cross check, Docker PS, you should see this is what the Terraform show was tracking. So this way, you tell the details and Terraform is going to just make sure that infrastructure is available. Okay, and anytime if I don't want, I can just say Terraform destroy. Now this is where when I say destroy, Terraform is going to destroy all the resources. Okay. But however, you can choose to destroy only a resource, but that will be again not an ideal process in your infra. So because you want to delete, you can delete. If not, you can just say Terraform destroy and go ahead and say help. You will get everything. So out of that, you can specify what is that you want to destroy. Okay, so you give the resource ID, and that is what it is going to exactly destroy. But anyway, now the container is also not there. The image is also not there. So whatever that you have told as a state, that is what Terraform is going to manage. Okay, so with
Adam,
this, yes,
uh, like we mentioned in Linux, I mean, whenever we need to remove some packages or files, we will mention remove. After giving remove command, we will mention that particular file name and folder name. In Docker, is that no need of while destroying, no need of giving that particular file. We are not
which file?
giving that image name. I mean, like whatever we are destroying now, we are not mentioning any
Exactly.
name there. Yeah,
That is what we call it as declarative. If you
yeah.
give everything manually where you are instructing, that is called as imperative.
Yeah.
Now, what did I tell to Terraform to create? That is my state. So my state included an image and a container. So same way when I say destroy, that is what is declarative method where you are not telling specifically. I am saying my infra. Go ahead and destroy my infra. What is that infra? One image and one container. So that is how it is going ahead and destroying it. Okay. So that is the whole logic that I want you to understand from this. So you are telling the declarative way in which you are telling your desired state, and Terraform will make sure to bring in which what is that you have defined. Terraform will cross check, and based on that available, it is going to bring up or not. Okay, so that is how it is going to manage.
I mean, like
Okay,
whatever we did recently, is that going to take?
it's not recently. What is that you have defined the state here?
Okay,
Okay, if this is the recent content of this file, Terraform will take only that. If you copy paste something else and put it here, Terraform is going to read that. So Terraform needs the state. So that you are going to give it in a file. And this file is what Terraform is going to read it. Okay.
sure.
So depending on that, whatever you run, Terraform will clearly try to say what is the state it needs. Okay, and based on that it says, okay, this file has two resources and right now you don't have both of that resources. Then if you do a apply, it is going to generate. Okay, so that's how
Any more?
Terraform manages. Yes.
Like Adam, in the resources what we have mentioned, the container name, the image, the keywords like name, image, ports, internal, external, are they the
Mm.
standard keywords or the user defined keys? What user defined keys, we can change
No,
that or anything?
those are standard. Now that is one of the headache that you need to start learning is you can't give anything. Okay, so if you go here, for example, this is the resource. So for every resource, there will be lots of keys. So you can see these are the different parameters or the key names that you have, and corresponding to it, there are different values. So like that for every resource, whether it is Docker resource or an AWS resource, you're going to manage. Same way. If you come to AWS, right? So if you see this AWS resource called VPC, you can scroll down and you can see these are the different blocks you have. So that is where first you need to know the concept of this of AWS, and then you should keep. You cannot just keep. But yes, to answer your question, these are standard keywords.
Okay, yeah. Even that includes name as well. Name also. Name
Exactly.
is equals to test ng. Okay, thank you.
Here, if you come down, there you have name, image, what you want to do. All right.
Irrespective of AWS, Azure, or Google Cloud, the Docker commands and internal things will remain the same, right? Will not change.
Yes, Docker will remain the same.
Okay.
This conference is no longer being recorded.
Yeah.
Okay, so just yeah.
The file name main.tf. This should be same, or can we change that file name? Like
We
test.
can change it, but for now, I want you to start with main.tf. Okay, so that's what I'm saying, right? Follow the footsteps. We'll come to
Yeah,
know
yeah, got
why, what, because we are not covering a couple of other things as of now. So first, today, what is that I want you to carry back is in Terraform, anything that you're going to write, you're going to use a file called main.tf, which is a file ending with .tf. You're going to put it in a separate folder, and in that file, you're going to have a provider block and a resource block. And how does it work? And what is the Terraform workflow, wherein how you're going to initialize, plan, apply, and destroy. Okay, so I want you to get familiarized with this concepts. So with this, as we move forward, we will try to add different state, different providers, and that is where we will use AWS and different types of resources in AWS, or again, we'll use a combination of Docker and a couple of things, and then see how does it work. So once you understand this logic, then it's about different other concepts that you have in Terraform when you try to write resources and different blocks. That language is what we are going to see. Okay.
Okay, thank you, Adam.
Yeah. Okay. So start practicing. Anyway, I'll share these notes to all your email ID. Okay, and the video will also be available in the app in some time, so you can just go through and practice. Any other questions?
Madam, I have one question. In AWS already cloud formation is there, right? So in real time, will they be using cloud formation or else Terraform?
Okay.
How will they choose?
So this is where, if you are a AWS admin and your focus is only on AWS, then you will be using cloud formation. But that is where when people are coming from different background, and for me to get started, I don't need to learn anything about cloud formation. So with just a simple tool like Terraform, you are going to now call yourself as a DevOps engineer or a person who has the ability to manage infrastructure as a code. For that, you can manage AWS or anything, because what is the difference between you and the person who knows Terraform? So it is not the choice of an organization, it's a choice of an individual. Okay. Assume if you go to a person who knows only AWS and cloud formation, and if you know that, using that, you are going to manage only AWS. If I'm your boss, and if I know that it's not just AWS, but we are also going to have certain things in future which might be on GCP or Azure, then I want you to have knowledge on a common thing, which is where I need to start focusing on implementing a process in the team or a company called infrastructure as a code, for which I need more things which is declarative and cloud agnostic. Then my preference would be in Terraform. Okay. So it's not about what is right or wrong. It's more about what is the easiest way. So this is where a couple of years back, when AWS was popular, only administrators were using AWS left in, left, right. At that time, CloudFormation was something they were using. But now, as we see, data center is one work, but in the name of DevOps, each and every one of us should know to manage infrastructure. So in that way, do you want to learn something which is cloud formation, or do you want to learn something which is cloud agnostic and easy, which is Terraform? So that is where Terraform is getting popular.
Okay. Okay. Thanks, Adam.
Yeah. Source code editor. I don't have any preference. So Notepad or Notepad plus plus, or you can use Edit plus plus, or if you're working on any Mac, I don't know if there's any editor, but yeah, that should not be a concern. I mean, if you are more of a developer, then you should be familiar with any IDE that you have, you can go through. But if you're more like a person like me, then yeah, use Notepad plus plus, which is a little better than Notepad. Or there's another tool called Edit plus plus. You can use that, or Edit plus.
Madam, one last question. When we are defining the Docker here, right, in the Terraform, it is again a container only, right?
Yeah, it's container only. Can you come again? Hello?
Yeah, Adam. So in the Docker, whenever we are defining something here, it is again creating under the container only, right?
Where? It depends. If it is a image resource, it will create image. If you say a container resource, then it will create container.
Okay.
It's a type
So
of
if it is
resource.
image resource, okay.
Yeah, both are separate resource, right? So type of resource is different.
Okay.
So Adam, Terraform, through Terraform, we can networking concept of the Docker, right?
Come again?
Can we handle the networking concept through the Terraform in Docker?
Yeah, you can do. That's what we are saying, a provider. See, the main thing is using Terraform, we are going to handle AWS or Azure. But Terraform also has providers to handle a couple of other things. Okay, so I'm just trying to tell you a simple way to first understand before I jump into AWS and show everything only to AWS. This is more for understanding the concept. But definitely, yes, there are different services and resource. So you can see for the Docker provider, you have a resource here. So if you are creating a Docker network specifically on this, you're going to handle using this resource. Okay. So that is where you need to know
Thank
what
you.
is that resource type. Using that, you can manage.
Sure.
Now, it can be anything. Now, this is where you need to understand what do you mean by internal and external. Okay, so internal refers to your container port. So when you run Nginx, Nginx runs on 80. So I cannot change this. But what is external? External is the port which you map to your host machine, which is like this that I showed you yesterday. Right? So can I change this 80? No, that is what is internal. However, can I change this 80, which is on my host container, I mean, the host port on the machine, which is mapped to container? Yes. So that is what you are going to do. So you need to know what is the image running, and from that, what port number will be exposed. So based on that, you will say internal, but external, you can choose whatever you give. So the equivalent of this is what we have given here. Okay.
If we have multiple containers, like multiple images, then can we assign different internal ports?
Not for image, it's for containers. Yes, you can do that. See, each image is going to have an application, and for that application, whatever the port you want, you can have. So I can take a image which will have Nginx, and I can say 80. I can have another image in which Apache is there. Instead of running on 80, I can configure my Apache to run on 90. Then I should create an image in such a way that inside it, when Apache runs, it will be exposing port 90. So that is from our side to know how to create that image.
Okay.
Adam, actually, I was thinking Terraform is replacing to Dockerfile, right?
No. Don't get confused with that. We will come back to that later. So Terraform is
Okay.
not replacing Dockerfile. Dockerfile is a different concept. What we have learned
Okay.
here is instead of you running some Docker commands, you can use Terraform. But moreover, my concept here I'm trying to tell you is before you are going to use AWS as an infra to manage, we are just using with the help of Docker to understand the workflow. So don't get confused with replacing with anything here. I want you to focus on the workflow here. And for that, use Docker, which will be easy for you to manage.
Okay.
Okay.
So is it like the Docker resources we are using or building up using a Terraform, Adam?
Not. Okay. I don't want you to get confused. Today, you are just learning the Terraform workflow. Okay. So I'll tell
Okay,
you
okay,
using Terraform what and all you can do. But we are just seeing an
sure,
option. Okay. See,
okay,
don't take in this way. But what if I say, if I'm teaching you how to make a call, so if I just show you, okay, to make a call, the simple thing is you dial the number. Okay, the simple number that I can give is 100, 100. Or if you dial like this, you will go. So does that mean that using the phone I can dial only 100? No, right? So it's the same way.
hmm,
Here we are trying
okay,
to understand the Terraform workflow, and this is just the first day. So for me, I have to give you some simple example that you can understand end to end. So for that, I'm just taking this Docker. So tomorrow we will see what are the
okay,
different use cases and things like AWS provider, and we will see the same. But on top of that, we will learn some new things.
okay. Thanks, Adam.
Okay. No, the .tf file should be in this syntax, or it should be a JSON. So there is no other format for your .tf file. Okay. So this is the only content that you want. So don't get confused with a couple of other concepts and tools, because Docker can also be managed by Terraform. That is what we will do. But here I'm just trying to show you, instead of you managing Docker directly, you can also use Terraform. And if you're using Terraform, what is the workflow? Okay. Okay, that's what I'm saying. Just don't just jump into too many other things. Right now, focus only on this. And as we move along, we will be able to see a lot of other concepts. Okay. So it doesn't mean that Docker is used only for managing, or Kubernetes is only for Docker. It's just more about understanding. Okay. Spaces, no, you will not get a syntax error. Don't worry. That's where I want you to start running Terraform validate and cross check. Okay. Sure. So start practicing this. I'll share it to your Gmail in some time. All right. And I'll talk to you guys tomorrow. Have a good day, guys.